Hi, my name is Mike Millhaem. I'm the 5G technical architect at Keysight Technologies. Today we're at GLOBECOM 2016 and we're showing some demonstration of the research work we've been doing in 5G digital pre-distortion, and we've been doing this work with the University of Waterloo in Waterloo, Canada. Basically, the problems we're looking at for 5G DPD is as we're moving up into the higher millimeter wave frequency bands in 28 and 39 gigahertz, we're going to be trying to do DPD on signals with wide bandwidth from the range of several hundred megahertz up to a couple of gigahertz. Typically, when we do DPD, we were going to use measurement and stimulus resources that have 5 times the bandwidth of the signals we're trying to measure. And when we're talking about signals as wide as a gigahertz, that can be very challenging. And the other aspect we're looking at is what we'd have to do special with multi-channel situations. For 5G, we're expecting to have phased arrays of multi-element antennas, and we want to look at, for digital pre-distortion, do we have to do separate pre-distortion for each individual amplifier? Can we use one pre-distortion algorithm for the entire array? And do we have to compensate for additional factors such as signal leakage from one amplifier to the next? So what we're using for that is we have a collection of instruments that we're using for our research projects. They're primarily high-speed arbitrary waveform generators and high-speed digitizers and scopes. And these instruments allow us to have the very wide bandwidths that are needed for this type of DPD. So let's take a look at the system that we're actually showing here. Here we have a block diagram on the monitor. We're using our arbitrary waveform generator, our M8195. This is an 8-bit 65 gigasample arbitrary waveform generator. We're using this to generate an IF signal centered at 4 gigahertz with an 800 megahertz modulation bandwidth. And then we've built a special up converter that we're using to bring the signal up to 28 gigahertz. On the receiver side, we're down converting that signal and then using our S-series oscilloscope to do the measurements. This is a 10-bit 20 gigasample oscilloscope, and we're using that to run with our 89600 software, and then from that we're using our system view software to calculate the digital pre-distortion and then to create the new waveforms from that. And with the information we're gaining from this will help us to answer many of the questions that we need to address for 5G digital pre-distortion. Thank you very much.